So hello coders, welcome to my channel, and in this video I'll be explaining the problem tree of coprimes. And to be honest, it is a really tough problem because not only it is difficult to think about the approach that what you have to do, but even if you haven't have a clear idea that what you have to do, then also it is a little bit difficult to convert that idea into an algorithm. I myself struggled with this problem for around 3-4 days and read numerous discussion like posts before arriving at the solution. So in this video, don't worry, I will be mostly writing the code and explaining it with this example so that the approach is clear to you. So let's briefly discuss that what I am going to do and like how I arrived at the solution. So the main idea to solve this problem is to keep track of the ancestors, keep track of the ancestors. Okay, so first of all, the first process to solve this problem is to create a coprime table. So basically, for example, in this case, the I have an array. Okay, and using this nums vector I will create the coprime of all the numbers. So for example, 3 has coprime in this array. 3 has 2, 10 and 5 are the coprimes of 3. Okay, 15 has 2, 2 has 3, 15 and 5. So it's pretty clear. Now the second step is to make a adjacency list. Okay, so in the problem I have been given information in this form and edges form. So using the edges, only the edges, I will create a adjacency graph adjacency list, so which will look something like this. It won't have these numbers 5 its values, so but values can be found out using the nums vector. That is, I have to use 0, like 0 represents 5, 5 represents what, 6. So this is how I have to use this adjacency list. The second step is to traverse, and the most important step, the fourth step is to take care of the ancestor. So how we are taking care of the ancestor is that, for example, suppose I am at 0. Okay, so right now my adjacent ancestor table will be empty. So what I will do is that I come at this node. I say that okay, 5 has coprimes 3 to 6. Now in the ancestor table I will find that do 3, 2 and 6 exist in the table or not. If I get the answer yes, they do exist, then I will try to find out their index. Like that's what I have to fill. For example, in 5 there is doesn't exist anything, so I will fill in my resultant table -1. Now what I will do is that I will, in my ancestor table I will add 5, and then I will go to the child. Okay, so if the child has 5 as its ancestor in the ancestor table, both the child. Okay, now I have 6. I know 6 has a coprime called 5, and 5 is the ancestor. Because how I can find it out? Because I will see in my ancestor table 5 exists. If 5 exists, I will go and fill the index of 5, that is what, 0. In 2 is also a coprime of 5, so I will fill 0 again. Now what I will do is that I will add now 6 to the ancestor matrix. So now the 3 has 5 and 6. So like this I keep on adding the ancestor in each recursive call, and then at each node I see and check in the ancestor table that whether this node exists in the table or not. So the structure of this table is going to be like this: number and a vector int, a pair of vector. It will be a map, so it will have the following values in the pair: the level of the ancestor and the index. Source is the index. Okay, so to explain this problem more efficiently, I will code it on so that the video is doesn't extend excessively, and I will explain it more in detail as I code. Okay, so as I said, my first step is going to be calculate the coprime table. So how I'm going to calculate the coprime table is that, first of all, I will make a unordered set, unordered underscore set, unordered set int, and I will name it coprime. Okay, so just one second. Unordered map, I'm sorry, unordered map, int comma vector of int. Okay, So this is going to be my coprime table. The first parameter is an integer, the second parameter is a vector. Okay, so how we find this coprime, just let me increase the font 15. Okay, so how I'm going to find my coprime is I will make an unordered set int s, and for int I is equal to 0, I less than nums dot size uh, I plus plus, and I will add nums s dot insert into the my unordered set nums I. And now what I'm going to do, I'm going to traverse this set and make the coprime number. So for auto n1 in s, for auto n2 in s. So if the underscore gcd, so this function is used for calculating the greatest common divisor between any two numbers, n1 and n2 is equal to 1. That is greatest common divisor between two numbers is 1. That is like they don't have any other divisor, it means they are coprime. Then what I am going to do is that coprime n1 dot push underscore back n2. So now just let me explain that what I have done so far. So I made an unordered set, and what I have made this because, see, I have to make this table, okay, and it can happen that in my nums vector there can be, for example, 10, there can be multiple tens, okay. So there is no point in making multiple tens, like again I will write down 10 and 3 here like multiple times if there are multiple tens. So to avoid that, I have made a unordered set of s size, and then I have filled it, inserted the numbers in nums, and then in the set what I have done this, I choose a number, for example I choose a number 5, and then I will do a square loop and see which numbers are the coprime of 5 using the gcd function, and then I put it in the map. So that's all I have done. So if you have any doubts, feel free to like write in the comments. I'm trying to make this video short because this is my second time recording this video, and another video went on to 30 minutes and I don't like it. So now my second step is to make a resultant array vector int res comma nums dot size. It will be of nums dot size, and I will fill it with -1. Why I have filled it with -1 is that just to make sure, like each will, if some number has don't have a coprime, okay, so it will by default be -1. Okay, so if a number doesn't have any coprime, to fill it at that time with -1, I am already filling it with -1. So my second step is now the second step is to create the adjacency graph, okay, which is going to be like this. Okay, so to make this, what I am going to do is that I will just, it is a pretty normal procedure for vector int adj sorry, nums dot size. Okay, so to make the adjacency graph, I will use the edges vector int I is equal to 0, I less than edges dot size I plus plus. In that I will create another vector int e is equal to edges I. So it's not really necessary to make this vector, but just I feel it easier to explain explain this way. So adjacency e0 dot push underscore back e1. Okay, and control c, control v, 1 0. So like I hope you already know this if you are watching this video, what is happening here. So this what this does is that helps me makes this adjacency matrix, like this graph basically. Okay, so now my second step is going to be Now I have to traverse this whole adjacency graph and do the thing that I am doing. So for that, what I will do is that first of all, I will make my ancestor table. Okay. So what it is going to look like is so right now the important part begins. Unordered map of int comma vector of pair int 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 int. Okay, ancestor ancestor. Okay, so I think the this arrows are good. One, two, three, fine. Okay, so this what these each number signifies is that the first integer means that the number. Okay, and the second in the vector, the first the first of the pair means the level of that current number, and the second one means the index. So you have to update the second one, matlab means that this integer is going to be the index. For example, when I was putting my 5 in my ancestor, after after visiting its nodes, what I was putting was that 5, 0 it will be its current level, and 0 will be its index. So this 0 is I have to put in my what array, if 5 is a coprime of some number. So just let me code it. So I will make three parameters in my DFS. I will make a DFS function. So it will have three parameters. DFS level is equal to 0. Some traffic is outside my house. Close the windows. Okay, so int level is equal to 0. Uh, int source is equal to 0. Int parent is equal to 0. Okay, now what I'm going to do is that I'm going to pass these three parameters in my DFS function. So DFS nums edj source parent level res. Okay, and in the end I will return my res. So let's make this DFS function. So in this DFS function, void DFS uh, vector int ampersand. I just have to copy this thing actually. Control C, Control V. Nums vector edges and adj int source int parent int level comma vector int ampersand res. Okay, so now I am in my this is the main function. So first of all, how do I find the ancestor of any particular so suppose it always gets some messy. Even the last time when I was explaining, it got a little bit of messy. So anyway, what happens is that suppose I am at any node, I have to find its ancestor. Okay, so a number can have many ancestors. Okay, you know this. So for example, let's say 2 has and then coprimes 3, 15 and 5. So suppose this was a fairly large tree and there were all these ancestors present. So what in the ancestor table I will hit all these ancestors 3, 15 and 5. So I have to choose the one that is the nearest to the my two's level. Okay, so this level is 1, this level is level 1, this is level 0, this is level 2. So and each level it will be increasing. Suppose this is level 80. So suppose I am at level 80, I will have to choose the highest level. For example, 78. If some coprime is present in level 78 in the ancestor list, so I will have to choose that one rather than the one that is present in 0, 1 or 2. So to do this, what I am going to do is that I will create a variable int max level. It will tell me that the max level that I am getting right now. So for initially let it be -1, because like each has a like, so we are starting from 0, that is why. So now what I have to do is that for int I is equal to 0, I less than coprime uh, co, uh, co, what coprime Just 1 second. Yes. So coprime of source. So here I was supposed to write coprime nums source. I have done this mistake, and in this line also I had to write coprime nums source I have explained it this in the end of the video, but this was a mistake on my side when I was coding. But for example, so please take care of this thing. So 5 will be having 3 to 6. So this will be the size, that coprime dot size, and cop is going to be each of these coprimes. So first I will check if in my ancestor list there does there any ancestor with value 3, any ancestor with value 2, any ancestor, then I will go on to 6. So that's what I am doing. And if uh, is not ancestor 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 coprime, uh, 1 second, coprime dot empty. So basically it means that if the ancestor of that number coprime is not empty, I mean it means that there is something. And ancestor dot ancestor cop dot back dot first is greater than max level, then what I have to do is that I have to update my max level is equal to this thing dot first, control C is equal to control V, and I also have to update my result. So result source, I hope okay, result source is equal to the same thing, ancestor dot second. Okay, so you must be having question that what is this thing. Okay, so ancestor uh, cop dot back first means that for example, if you see, for example, just like take the number 5. Okay, so what is 5 going to be look like is that the any first one is 5 0 comma 0. Okay, so the first one means the level. There can be many ancestors whose number is 5. Okay, so one ancestor can be at level 0, one ancestor can be at level 2, and its index can be something x. So another ancestor can be suppose at level 75, and its index can be something 100, say 100. So since I already have this last one, it means that my current node, the node that I am looking, has a level higher than 75. So if it has a coprime called 5, it will be in my best interest to choose the one with is the highest level. So the highest level will always be the back one. So vector dot back, so this is the dot back points to the last entry in the in my pair of vectors, and this is going to be its level. So if the level if its level is greater than the max level, then it means that okay, it's time to update the max level, and 100 is going to be the index that I have to fill in my resultant table. Okay, so that is the toughest part of this problem, to write this piece of code. And now what I have to do is that I have to add the current node into my ancestor table. So and then I have to traverse. So ancestor nums src nums source, okay, dot push underscore back level comma source. Okay, so done. And now I have to do what I have to do is I have to make a for loop auto child adj uh, so this is basically a depth first search, and I know you know it. If the child is not equal to parent, then what I have to do is that I have to do a dfs nums comma adj comma src. So the new source will become what? For the next recursive call, the new source will become the child, the parent will become the source, and level will increase by 1, and res will be the same. And after that call from one level is over, I have to pop back the the current node from the ancestor table. Why I'm doing is that doing this is because pop back doing this because see, this ancestor is a global variable. If it was like I was yes, if I was passing it locally from this locally from each call to each from in using a parameter in DFS, then it would have been fine if I don't write this thing. But since it is a global one, I have to pop back the current node. So if you do a little bit of dry run, you will realize it. So now just let me run this code to see if the algorithm that I have coded is correct. It may have mistakes. So push back, okay, it should be back, BACK, okay, insert back. Uh, I hope it runs. Push back. Oh, sorry, I'm so sorry. I had to write pop. It happens when you are trying to speak and code and explain. ADJ, undeclared identifier. Okay, now I have not identified it here. Oh God, why is this wrong now? Okay, so what I was doing wrong here is that it has to be nums src, and it also has to be nums src. So this was the mistake. So basically what I have to do is the nums of src. I hope it works. Okay, it is working. Now let me submit it. Okay, so it is passing the code. So what mistake I did was that it is nums src. So nums src means like I have these numbers 0. Okay, so for example, I am at 2. Okay, I am at 2. Now I have to find the coprime not of 2 but the number that is present at 2. So the number that is present at 2 is 6. Okay, so 6 is far, the number that is present at 2 is 6. So that's why I had to write nums of src. Okay, so like even if I knew what I am doing, then also some mistakes are bound to happen, because it's quite difficult to implement. So I hope the solution is clear to you. If you have any doubt, you feel free to write in the comment using the timestamps where you are having a doubt. I will try to clear them. Okay, folks, so that's all for this video. It has been already been a pretty long video. So if you like this video, please consider subscribing the channel. And thank you and have a nice day.